Hello and welcome to Custom Events and Metrics, part of the Monitoring and Troubleshooting Applications with Application Insights course. In this module, we will discuss how to track your own custom events and metrics with Application Insights. My name is Kevin Griffin. I'm an independent software consultant and 10-time Microsoft MVP, focused in ASP.NET development and deploying solutions to Microsoft Azure. It is my pleasure to teach you some of the ins and outs of Application Insights and how it can be beneficial to your projects. In this module, we will talk about tracking data items that are not covered by Application Insights by default. First, we'll begin with a discussion of what a custom event is in Application Insights and how to use the Application Insights SDK to issue custom events. Next, we'll talk about tracking custom single and multi-dimensional metrics with Application Insights. And finally, we'll touch on some other types of data you can track with the Application Insights SDK. In this section, we'll discuss what custom events are, how to track them with Application Insights, and how these custom events can be tracked in the Application Insights portal. Let's begin with the definition. What is a custom event? Simply put, an event is something that happens in your application that you would like to track. You could think about it from a user interface perspective. The user hovered over a button. The user clicked on the button. From a server standpoint, you could say the user visited the account page. Along the same lines, you might even have events that don't occur all the time. What if you tracked user logins and raised an event when the user had logged into the application for the 100th time? This still qualifies as an event. Furthermore, events don't need to be centric around users. In some of our applications, it's common to raise events when the server restarts, so we can track how often this occurs. Most SDK communication with Application Insights is done through an object called a telemetry client. More on that in a moment. But with the instance of a telemetry client, you can call the method trackEvent to send an event. As you might notice, the trackEvent method takes a magic string as its parameter. It would be advisable to use a string constant for the event name instead. This will maintain consistency throughout your application, but also allow you to change the event name without having to find and replace across every line of code. It is also possible to send metadata with your events. By using a string dictionary, you can add as much metadata as you want and send it along with your request. In our example, I'm making my executingDB query event a little smarter by adding metadata for the query we're executing and possibly any parameters needed for the query. I mentioned earlier, you need to have an instance of the telemetry client to send events and other types of metrics to Application Insights. The telemetry client is an object that knows how to sample and send telemetry to your particular instance of App Insights. Commonly, it is instantiated when your application starts up, and a singleton object is passed around to any part of the application that needs to use it. In .NET Core and ASP.NET Core, it is highly recommended to use the .NET Core dependency injection pipeline to accomplish this. In our next demo, you'll see exactly how this is done. However, there might be cases when you are not able to use the .NET Core dependency injection pipeline. In these cases, the current guidelines are to either create a singleton instance in your own dependency injection implementation, or create a static global instance of telemetry client that can be accessed by anything. The key point is that you're only working with one instance of the telemetry client in your application lifecycle. In this demo, we will walk through a live code example of adding some event tracking to our applications. Then we'll explore how to expose these custom events inside your Application Insights. As we dive in, I've already set up a little bit of a test project. You might have seen this project before somewhere else, but it's called the stress controller. And the reason it's called that is that I am running stress tests against it. And this is all tied into Application Insights to get a little bit of telemetry. And what I like to do is take this example controller and add a little bit of extra telemetry to it that we can pull out of Application Insights. Now, first things first, before I can do any telemetry tracking, I have to add an instance of the telemetry client. That is done by injecting the telemetry client into our constructor. Now, if you're not familiar with dependency injection in general, what's going to happen is at runtime, when ASP.NET Core tries to instantiate an instance of the stress controller to handle any calls that come in, it's going to request an instance of the telemetry client be passed into it. ASP.NET Core will take care of this for you automatically. You don't need to do anything special. So we'll get an instance, we'll save it away for later as a private variable, and we'll scroll down to our getDBResult method. This method is pretty simple. We'll make a call to the database, get some results, and return them. And when this occurs, I want to just make a simple call to Application Insights, marking that an event has occurred, that a DB request was made. I'll add a line to my method, accessing telemetry client, calling the track event method, and passing in the string of the event name. Now remember, this is a magic string. You could encapsulate this as a string enumerable somewhere else, but I'm just going to use the magic string for example. And we're going to save this, and we're going to push it out into production and show you a couple of the requests coming in. Now I'm in Application Insights Live Metrics, and as you can see, I had a little bit of traffic that was coming through earlier. It's clearing out now, and I'm going to send some traffic in. Now that I have my newly added track event method, let's see what happens inside of Live Metrics to register this particular event. And it really takes no moment at all. I have a lot of traffic coming in, and you can see DB request is popping up inside of sample telemetry. And this is telling me that the event occurred, when it occurred, and any other metadata about the request is included at the same time. Now, this is really useful, but what if we wanted to add even more context to the event other than just the name of the event occurring? Well, to accomplish that, we'll go back to our code, and we're going to add a string dictionary. And inside this string dictionary, we're going to add maybe just what the query is. You can add any information in here that you want to, as long as it's in a string. That can include JSON, that can include numbers, objects, whatever. As long as it's a string, you can pass it in as metadata. So I'm going to pass in the query that we're calling, because maybe we want to look this up later inside of the analytics. So I'll pass in query and then the actual SQL object itself. But you can pass anything in here as you want to. So we'll pass another one. We'll just call it number and 42. We'll redeploy this application and see the new information in Application Insights. Over back in Live Metrics, I've cleared everything out again, and we'll restart our background servers. And now we see new sample telemetry coming in, but there's more metadata. I can click on any one event, and you'll see that not just the name is included, we also have our query, and we have the number that we want to track. Now, you can populate this with whatever you want. So you don't have to do just the examples that I have here. Any metadata that's necessary for you and your application can get passed in. Now, one last thing I'd like to show you is another way that we can see the metrics, and we're going to dive into this a little bit deeper. But from the Application Insights main overview page, if I go to logs in the sidebar, this will take me to the log analytics view, and we have an entire section that will discuss this. But for now, if I want to look at just custom events, we're going to time range it just to the past 30 minutes for this demo and click run. This will load all the raw data that's in Application Insights regarding custom events that occur in our application. So I can come in and see, well, here's my custom event, DB request. I can open it up and see there's all kinds of information about that request that's getting stored for me. So in addition to the name of the request, name of the event, There's things like the client IP address, where the client is coming from. There's things about my application, the SDK that I'm using. This is a lot of metadata, and Application Insights is tracking all that for you automatically. Now, if we collapse this and sort by a different time range, we have some of our newer requests that had additional metadata in it. So I'll open the top one here. And we'll see it's still a DB request, and I have some custom dimensions or custom metadata. And you see my query. So the query that I passed in is there. It's good to go. So there you go. That's just a different way of looking at your data, and we'll dive into this more later. But for now, that's how you use Track Event with Application Insights. In this section, we'll discuss what custom metrics are, how to track them with Application Insights, and how these custom metrics can be tracked in the Application Insights portal. What is a custom metric? Similar to an event, which is a data point you can track when something happens in your application, a metric is a series of data points you aggregate and track over time. While Application Insights is very flexible on what you deem a metric, here are a couple of examples you might think of. First, tracking API calls to your system. While Application Insights can directly do this for you, maybe you want to break it down a little deeper to say out of 1,000 API calls within the past 10 minutes, 250 of them had been people on the bronze plan, 700 of them had been on the silver plan, and 50 of them had been on the gold plan. Another metric Application Insights tracks for you automatically, but proves as a good example, is CPU and memory utilization over time. Maybe this is a step further and tracks other performance metrics, such as hard disk utilization, which is something Application Insights doesn't track for you at the moment. And the last example might be tracking the number of concurrent users using your application at any one time. Application Insights supports two types of metrics: single or zero-dimensional metrics, and then multi-dimensional metrics. A single-dimensional metric is a simple number you're tracking. For example, let's imagine we're tracking users that are currently logged into the system that reside in the United States. This will only ever be a single integer. Of course, that integer could change. Initially, it might be 50 users, and then a minute later, it's 75. We're still only tracking one data point. What about multi-dimensional metrics? While this boils down to only being one number tracked, we're separating the metric by multiple dimensions. In our example of counting users logged into the application within the United States, we can easily transform this into a multi-dimensional metric by tracking the users in the United States by the state they reside. One dimension is the users logged in within the United States, and the other is the state they reside. These examples might make more sense with code, so let's run through both examples as though we were building out the tracking infrastructure with the Application Insights SDK. This example, we're gathering a metric called connected in the United States, and it's passing an integer collected from another part of the application. Application Insights will aggregate these metrics across all the instances of your application and present them to you in graphs and log analytics. In this example, we're creating a multi-dimensional metric. First, we'll start by getting a reference to the first dimension of the metric, or states. And from that reference, we can track second dimensions by calling the track value method and passing in the metric number and the name of the second dimension. Application Insights again will aggregate this data and show you total numbers for the first dimension as well as individual numbers for the second dimension. We've said before that Application Insights will aggregate the data you send to it for graphs and log analytics. However, it is expected of you to send pre-aggregated data. To put this into context, if you're reporting the number of users logging into the application, you wouldn't want to report the metric on each login. Instead, you should collect the number of logins and send them on some sort of interval, maybe 1 minute, 15 minutes, or possibly an hour. In this demo, we will walk through a live code example of adding some metric tracking to our applications. Then we'll explore how to expose those custom metrics inside of Application Insights. And we're going to talk about both single and multi-dimensional metrics So first, let's start with single. This is a little bit easier to talk about. And we're going to do some work in this method called delay. When it's called, it's going to wait a random amount of time, and then it's going to return OK, unless certain conditions exist where it'll throw an exception. What I like to do here is track the number of delays. What's the random number over time? And every minute or so, I want to send that metric to Application Insights to track for me. Well, let's do a little bit of prep here. Outside of my delay call, I'm going to add two static methods. The first one is going to be called last metric sync, and that's just the time for tracking last time I did a sync. And the second is going to be a list of the different delays as they occur. It is also a good idea to enumerate these immediately. Another alternative, if you didn't want to do it this way, is you could use a static controller, which I'm not going to use, but you could if you wanted to. Then down here in our method, I'm going to add some code here between pulling the random number and then the delay. Let's walk through this code. First, because we have the random number, let's add it to our list of random numbers. And depending on how often this delay is called, this list could be pretty short. It could also have a lot of numbers in it. And then I want to track to see whether or not I should do a sync. Now, this is one way of solving this particular problem. Normally, if I was in a production app and had a lot more time for setup and management, I'd probably have this running as a background service. And I would report all these metrics to some sort of other shared data store. But we're in demo land. I'm just trying to prove the point. So we're not going to worry about all that ceremony. So all I need to do is look at what's the current time now, and what's the time difference between the last time I did a sync and now. Now, if the minutes are greater than 1, that means it's been at least 1 minute since the last time I've done a sync. So we'll go into our delays list, which is just a list of numbers, a list of integers. And I'm going to use link to find the average of the numbers, because that's what I want to send over to Application Insights, is just the average. I'll call into telemetry client again. This time I'll call the track metric method, and I have to pass in two pieces of information. The first is going to be the name of the metric that I'm tracking, and this is just called average delay. And then I'll pass in the actual number itself, the actual average. Now, assuming I've sent this, I can clear my list and start over again. We'll reset the last metric sync to now, and things will go along its way. And then the rest of the code continues. Well, let's go ahead and get this code deployed. Let's show you it working up in Application Insights and how you can pull it. And we're back in the Application Insights portal. I've been running my background services for a while. We're kind of stressing the system, and I want to go in and show you how you look up the metrics for the code that we just added. And this is done by going on the left sidebar to the metrics section. And this takes you into a build your own chart platform. Now, for your application, there's a lot you can do here. You can add multiple metrics to the same chart. You can add filtering and splitting. Right now, we're just interested in adding the single metric because we only have one number that we're trying to visualize. So up here at the top, I'm going to select log-based metrics by default, and then I can choose from the various metrics that are provided to me. Now, a lot of these are built in to Application Insights by default, but if we scroll down, there's a section called Custom Metrics, and you'll see average delay is sitting there waiting for us. If I click that, I'm going to change my time range to the past 30 minutes because I have a solid amount of data from that time. And you'll see all my different average values are being displayed here on the chart. And just for your knowledge, you can view this as a line chart as we see here. You can see this as a bar chart. You can also look at it as a scatter or area chart. it doesn't really matter how you look at the data. Because it's one dimensional, you're only going to see one set of data. Next, let's talk about multi-dimensional metrics. And these are going to be metrics that have more than one dimension associated with them. And for this, I'm going to create an entirely new method. And through the magic of editing, I've just added it here so you don't have to see me typing everything out. And let's walk through this example. So this endpoint I'm going to call from locale. And it's got a definition that says I'm going to take in a state and a city. And these are going to be different dimensions of my metric. So there's going to be the state metric, and then there's going to be the city metric. And the first thing we want to do is just make sure that our values aren't null, because we really don't have that protection built into the demo. And I'll talk about why I have a lock on this method here in a moment. It's just because this is crazy demo code. We wanted to add a little bit of thread safety. And what I want to do is anytime a call is made to this method, I want to tally the state-city combinations. And the way I'm accomplishing that, even though there might be several different ways to solve this problem, is by using a multifaceted string dictionary. So a dictionary that uses a string key, and that holds another dictionary with a string key and a number. So when a request comes in, we're going to see if the state exists in the initial dictionary. If it doesn't, we'll create it. And then we'll see if the city exists in that new dictionary. If it doesn't, we'll create it and set the initial value to 0. So that means I can increment that number. So let's say, for example, my state is Virginia and my city is Virginia Beach. Well, if it's in there, I'm going to increment its tally by 1 and reassign it. Now the next section here is similar to the demo we did before. We're going to check to see when was the last time I sent metrics up to Application Insights. And instead of recording this in terms of minutes, I'm going to look at total seconds. So if I look at the current time versus the last time I sent metrics up, if it's been more than 30 seconds, I want to send the metrics. And this is done a little bit differently. We'll ask the telemetry client to get us a reference to the metric that we're going to call API hits. And it's going to have 2 dimensions, the state and the city. Now with this metric defined, I can go through my dictionaries, so through all the states and then through all the cities. And for each state and city value, I'm going to send or track the value by pulling the integer out of the dictionary. So this should be some number 0 or more. I'm going to send in the value of the dimensions. So if my state was Virginia, I would pass in Virginia here. If my city was Virginia Beach, my city key would be Virginia Beach. And then when I'm all done, this will clear and I'll reset my time and everything will be good. Now, just for sake of argument, why am I locking this? This isn't the ideal way to solve the problem, but things like tracking values and obtaining metric references, these are not thread safe. So if you were to run this in a production environment where you were hitting this endpoint over and over and over again, there could be a case where 2 competing calls were trying to access the same reference at the same time, and you might get an exception. So by locking this particular method, I am preventing that from happening in my demo. So let's take this code, let's deploy it, and see what happens inside of Application Insights. We're back in Application Insights. This is the metrics chart screen again. And we're going to walk through the same process that we walked through before with single dimension metrics. I'm going to scroll down to custom, hit API hits. I'll change the time range to 30 minutes, again, just for clarity. And as you'll see, there's not much difference between this view and the view that I had before with a single metric. I have API hits, and it's just the number. It's the average over time. How do I get the information for the different dimensions that I did have? On this chart, we can apply splitting. And this means take the API hits and let's split the data based off another metric or another dimension. In the list are all the dimensions that I can choose from. And notice it's not just the metrics I'm sending in, it's also information about the request where the metric is coming from. I'm going to scroll down to city. I have 2 cities. This is more of a mistake on my part. One of the cities is sent in by Application Insights, and the other city is the one that I send in. I'll select the second one because I know that's the city I'm talking about. And after a moment, you'll see I don't have just one line on the line chart. I now have multiple lines on the line chart. And they're all color-coded, and down at the bottom, they represent the various cities inside of my metric. If you want a slightly easier way to view this data, go to the chart selector and choose bar chart. And now the chart is a little bit easier to read. The next thing you might want to do is filter this down a little bit. Because I'm seeing every city in my metric, I might want to filter this down by the state where the data is coming from. And this can be done by clicking on the Add Filter button at the top of our chart. Again, another drop down with all the metadata for my particular metric. I'm going to scroll down to state and see I have state and then state or province. State or province is the one provided by Application Insights. I'll select just state. I have to select an operator. I only want to choose options where the state is equal to Virginia. And this will filter my chart down even more. If I change or add multiple values, the chart will automatically change itself to reflect the values that I'm asking for. You can then later take these charts, you can pin them to your Azure dashboards, or you can save them as alerts, as we'll talk about in a later module. And that's multidimensional metrics in a nutshell. So far, we have covered the more commonly used tracking methods in the Application Insights SDK. However, there are a couple additional methods that might be used in your apps. First, let's talk about track exception. And I know what you're thinking. Doesn't the SDK track exceptions by default? And the answer is usually yes. However, in cases where you catch an exception, it won't filter to the SDK exception handler and will be lost. And it depends on what your intentions are by catching the exception. Typically, if you're able to catch the exception, you're able to handle it without needing a record of it occurring. In those cases where you need to both track an exception and handle it, track exception is available for you. Additionally, there are cases where you'll want to provide extra metadata for the exception. As we've seen with other telemetry methods, this is always an option. Let's see an example of both cases. Here's an example of using track exception in a common workflow. If you have a try-catch block, you can pass the exception directly into Application Insights for tracking. Be careful not to rethrow your exceptions though, because that is a good case where Application Insights could track the exception a second time, leading to inaccurate data. Here's another example. This time we're passing additional properties to the track exception method. Early in my programming days, I learned debugging by writing simple debug messages that would allow me to retrace my steps back to where an issue was occurring. No logging platform would be complete without this functionality, and Application Insights has you covered. Track Trace allows you to send simple log messages. In this example, I'm channeling my early debugging days by giving myself context of where I am in my code base. You can set optional severity on any track trace call. And furthermore, you can also send additional metadata as we have seen in other examples. Finally, we'll talk about track dependency, which is another method in the list of things that Application Insights will do for you automatically. However, cases always exist where you might want to track the success or failure of a dependency and its response time separately from anything done by Application Insights. And track dependency exists for this purpose. Here's an example of using track dependency. Unlike some of the other methods, there's a little bit of setup you should do to prepare for using track dependency. There are several overloads for this method, but let's walk through the most common and precise signature. Now, first and second, we want to tell Application Insights the name and method we're calling. Some overloads of the method will only require you to pass a name, so don't worry if you don't have everything abstracted out. Third is any data you'd like to track about the call, maybe a string query or some JSON of the payload. Now this is optional, so a null would suffice if you don't have data to pass. And fourth and fifth are parameters for timing. As you can see at the top of the example, we track when the call begins and how long it takes. Both of these can be passed into application insights for tracking. Finally is a success call, which simply tells application insights if the dependency succeeded or failed. This is always important to pass so you can get accurate metrics from the portal. In this module, we've covered some of the ways we can use the Application Insights SDK to send our own custom telemetry outside of what is provided by the platform by default. We talked about tracking custom events in our applications, whether it is someone logging in or someone performing an action on the UI. We can track these custom events and then aggregate them within Application Insights. We talked about tracking our own custom metrics. Maybe we want to know the number of users logged in from Virginia versus Texas. And then finally, we talked about a couple custom types of telemetry that normally Application Insights does for us, but we can use for a little added benefit. Thanks for listening to the Custom Events and Metrics module, part of Monitoring and Troubleshooting Applications with Application Insights course on Skill Me Up. My name is Kevin Griffin.